So keeping in mind that these VESC and ESCs are basically pulse width modulation DC motor speed controllers with methods to enhance the efficiency. If I was building a skateboard that only needed to do 25-30 miles an hour, check out how I built this. So these cells can flow 7 amp continuous, 12 amp burst. I've got it in a 5P configuration. So 7 amps times the parallel group totals, that's 35. 7 amps times that is 35. And then 12 amps times 5 is 60 amps. So that's a total of 540 watts. So pulse width modulation has a duty cycle. The duty cycle basically averages down the voltage over time. So 25% of 84 is 21 volts. At 30 amps, that's 630 watts for max continuous, or at 40 amps, that's max burst, that's 840 watts per motor. So this is times 2 is, I don't know, 1600 and something total. So at 35%, so we have an 84 volt battery that is in the Eskate calculator, it'll do like 56 miles an hour. I'm only going to take it to about 25, 30, maybe 35 if I'm falling off of a cliff or something. So at 25%, at 35% duty cycle, that's around 29 volts average. Now at 30 amps for max current, max continuous, sorry, that's 882 watts. Times 2 motors, that's 1700 watts. Is that less than this? So are we pushing these cells past 5 amps each here? So check out this. At 40 amps, which is max burst, that's 1160 watts times 2, or 2300 watts. Okay, so at 45% duty cycle, we're at 1140 times 2, that's 2200. Okay, so then at 40 amps, we're at, oh shit. So only pulling 7 amps per cell, or 12 amps continuous is 5,000 watts at 12 amps per cell. So 55% duty cycle, 46 volts, 30 amps, 1300 watts, 2 motors, 2700 watts. Okay, so at 55% duty cycle, this is running at 3600 watts. 65% duty cycle. Finally, at 75% duty cycle, I am starting to outrun my batteries. And guess where the VESC tops out at? 95% duty cycle. I rest my case.